You're watching Keystone Science, and in today's episode we're going to show you how to make a miniature musical Tesla coil. Now in last week's video we made this little desktop-sized Tesla coil, and from that video I got quite a bit of requests on how to turn it into a miniature musical Tesla coil. And so hopefully in this video we'll be able to accomplish that. So if you have not already yet, go ahead and watch that video because it'll be a little bit of a precursor to this project. And so with that all said, let's go ahead and get started. And so here's the new circuit that we're going to be using. Now this circuit is probably the most simple circuit I've ever seen for a miniature musical Tesla coil. Now what this frequency symbol means in this case is going to be our audio input. Now both the capacitors are going to be 1 microfarad, however it's very important that this capacitor down here is ceramic. If you try to use an electrolytic capacitor down on this side, it'll likely explode due to the high frequency oscillations. As used inside of last week's video, we also have a few voltage dividers. These are necessary to ensure that certain components don't get fried due to a higher voltage than they can handle. In last week's video, the MOSFET we used was an IRFP 260N. Now in this circuit you could use this MOSFET, however since I only plan on running mine from around 18 to 24 volts, I'm going to use a much smaller MOSFET. Now I'm making mine to more be a desk toy than anything. And so as the power source I'm going to be using this AC-DC adapter that outputs 18 volts at around 2 amps. Now if you don't have an adapter like this, you could probably also use an old laptop power supply, as those can also output around 18 volts. To first build out the circuit I'm going to be using a breadboard like this. As I build this out, I'm going to be putting check marks next to each component. And soon after the video is uploaded, I'll hopefully have a website where I'll upload the schematic. And so if you'd want, you can print off the schematic from there and then follow along. The first component that I'm going to be using is this 2 kilo ohm resistor. And so as you can see here, it needs to be connected up to the positive side of the power supply. And so I'll just insert one side into the positive rail and another into row 24. The next component we'll be using is a 10,000 ohm resistor. And so I'm going to take that and connect it onto row 24, connected up to the first resistor, and then lead it to row 19. Next from there we have a 2,000 ohm and a 10,000 ohm resistor in parallel with one another. And so on my breadboard I'm going to connect both of those resistors to row 19, and then I'll connect them both up to row 13. Now the next component is an LED like this. Now LEDs need to be oriented in a certain way, going positive to negative like this. And so we're going to take this LED and connect the positive side to these two resistors, and the negative side is going to be going to the negative rail over here. Now for my MOSFET I'm going to be using this guy right here. The pin out of this MOSFET goes ground, drain, source. And if you're curious, here are some specifications on it using my transistor tester. Since the MOSFET itself may get hot during operation, it's a good idea to put some thermal grease on it and secure it onto a heatsink to help it dissipate out the heat. And so now, as shown in the schematic, that MOSFET needs to be connected to the first two resistors. And so I'll insert the MOSFET onto this rail over here, and then I'll use this wire to connect the first pin of the MOSFET to the junction point between the first two resistors. Now the drain of the MOSFET needs to be connected up to the positive power supply. And so I'll just take this wire from pin 2 of the MOSFET, and I'll connect it up to the positive rail. And now the source and third pin on our MOSFET needs to be connected up to the junction point between the second resistor and these two resistors in parallel. And so I'll run another wire connecting the third pin of the MOSFET to that junction. Next I'm going to be using this transistor. Now the pin out of this transistor from left to right goes base, collector, emitter. On the schematic, this is our base, this is our collector, and this is our emitter. Once again I'm going to apply some thermal grease, and then once again I'll secure that onto a heatsink. And so I'll insert that transistor right here. Pin 1 of that transistor needs to be connected up to the same rail as the positive side of the LED. Now I'm going to take this 1 microfarad ceramic capacitor, and I'm going to insert it between the collector and the emitter of the transistor. So in my case that's pins 2 and 3. Now I'm going to take a wire from pin 3 of that transistor and connect it up over here to the negative rail. For the audio input I'm going to be using this audio jack. As you can see on the bottom of the audio jack there are 5 different pins. The far 2 left pins are going to be our left side of our audio, the middle pin is going to be ground, and the far right side is going to be the right side of the audio. Now in this schematic I'm going to be using the connection from ground, and then you can also use either the connection for the left side or the right side audio. And so I'm going to insert the audio jack into these rails here on the breadboard. I'm going to be using this 50 volt 1 microfarad electrolytic capacitor. Now the polarity on this capacitor shouldn't really matter, so I'm going to connect it from these 2 pins here. And then the other end of this capacitor needs to be connected up to the gate of our MOSFET. And so I'm going to take a wire and connect the opened end of the capacitor to pin 1 of that MOSFET. And now for the ground of our audio, I'm going to take that ground pin, which is the center, and I'm going to connect that up to pin 2, or the collector of the transistor. And so now the last step we're missing is to connect this primary and secondary coil of this transformer. Now the turn ratio here should actually say something around 400 to 1 turn. That is 400 turns of wire on the secondary and 1 turn on the primary. And so for this I'm going to be using the coil that we made in last week's video. The secondary coil is around 30 millimeters in diameter, and it's around 400 turns of 32 gauge magnet wire. And then the primary is just wrapped around at once. And so on the schematic here we can see that one end of the primary coil needs to be connected up to the junction between the second and the 2 parallel resistors, and the other end of it needs to be connected up to the collector of the transistor. And so I'll connect one end up to pin 2 of the transistor, and the other end will be connected up to that junction point. Now for the secondary coil, we need the negative end of one LED connected up to one side of the secondary coil. And so I'm going to connect the positive end of that LED up to this row here, and the other end of that LED is going to be connected up to one end of our secondary coil. And this should be the full schematic, so let's connect it up to our power supply and see if it turns on. Okay, now I have the lights turned off and I'm going to go ahead and turn on the power supply to see if it works. So as you can see, we are getting a musical arc to come out of that needle. The sound quality honestly isn't that bad. Now as you can see, just like a regular Tesla coil, this will light up things like neon lamps from fairly far away. And of course it will also light up fluorescent bulbs like this. Now if when you start it off you don't get that corona coming off the top, then there are 2 things that could be wrong. The first thing you should try doing is try reversing the primary coil connections. In other words, it may be so that the 2 coils are more cancelling each other out than helping each other. And so by reversing directions, they'll align their magnetic fields and that'll hopefully make an output on the top. The second thing that may be a problem is this 10,000 ohm resistor up here. You won't get a great output if that's not in tune with your coil. And so to help fix that, I think you could turn this into a 50,000 ohm potentiometer. Start that potentiometer off at 50,000 ohms and slowly turn it down until you see purple discharges off the top of this. And the moment you see that stop, take off the potentiometer and measure that resistance. And then you can just replace this resistor with the specific resistance you found that goes in tune with your Tesla coil. Anyways, now that we know how this all works, I'm going to take this circuit and solder it onto a perf board. And then I'll try to make a nice little enclosure for everything, and I'll come back to you guys when I'm done with that. And so here's the final product. Now this container was the only one that I could actually find, and you may notice that the coil is actually a bit smaller. In fact, as a size scale, here's the regular coil that we were using before. Basically, I couldn't fit this 30mm coil inside of here, so I wound this coil. Instead of the 30mm, this coil is around 20mm in diameter, has about the 400 turns, and is using 34 gauge magnet wire. And then I have 3 sets of wires going out. First off, this wire here goes to the 18-volt power supply that I was talking about before. This wire here is just the aux cord heading out. These 2 wires I added down here are just in case if I want to try something like 24 volts rather than just the 18 volts. As you can hear, it does produce quite an audible sound, and it's not too painful to touch. Now this discharge out the top would be bigger if you're using a higher voltage. And so if you want to try running this at a higher voltage, just be sure that you're using the correct components. So for instance, instead of using the small MOSFETs I was using, use something like that IRFP260N MOSFET, as well as perhaps a stronger transistor. Okay, so now as a test I'm going to switch my lens into a lens that can zoom up very close, and we'll see if we can see any sort of frequency patterns happening inside of this. However, I do question whether the camera will be fast enough to pick up any sort of waves. So from that frequency test, you could see at some frequencies it was a little bit more chaotic than at other frequencies. Now I am very curious to see what it would look like with a very good camera to zoom way up close on this arc and see those frequencies very close up. So now you know how to make a miniature musical Tesla coil. Thank you all so much for watching the video. We're fairly close to 100,000 subscribers now, so I thank you guys so much for that. Anyways, if you enjoyed this video, I'd really appreciate it if you leave a thumbs up, as it very much helps the channel. And if you're new to the channel and would like to see my weekly science videos, go ahead and hit the subscribe button so they'll show up in your subscription newsfeed. If you have any suggestions for projects you'd like to see me try in the future, go ahead and leave it in the comment section below. And also, if you guys need help with anything, go ahead and comment it down below and I'll try and help you out with that. So anyways guys, please remember to be safe, and have a wonderful day. You're watching Keystone Science, and in today's episode we're going to show you how to make your very own desktop-sized Tesla coil.